Okay, so we're going to use similar triangles to solve problems. To use similar triangles, properties of similar triangles. How many triangles do you need? At least two, right? Do you see two triangles here? Yes, so one right here and one right here. So that's what, those are the two triangles you want to use to compare to figure out the what you want to solve for. So using property of similar triangle, find the width of the river to the nearest meter. So the width of the river is this right here. I'm going to call it X. Okay. This is a river because it has a fish in it. Okay. So now if you rotate this triangle to match up with this, what do I compare with? It will be 50 over what? So looking at this triangle, this top triangle right here, okay, I will compare the 50 side to which side, Kelly? Or 50, ooh.
Oh, my bad. Oopsies. 17.
17. Right. Okay, so you're comparing this length right here with this length right here. Okay. Equal, I want to solve for x. So I have x over 15. Does the order matter on how I write these two fractions? So can I write 15 over x? Yeah, so the order does matter. If you start with a big triangle, this side you have to also start with a big triangle. All right, so you have to start with the same. Yeah. All right. So cross multiply, and I get 17x equals 250. 50 times 15. 50 times 15, 750. And then when you divide it, 750 divided by 17, you get 44.1. And what's my unit? Meters. Good. All right, because it's meters right here. So that means, therefore, the width of the river is 44.1 meters wide. Similarly, Kelly said this as well. At the beginning, when I said 50 over, she told me 50 over x. Okay? You can write it like this as well. And then this would be 17 over 15. Because they hold the same ratio, you could do from the same triangle, like this length with the width, compared to the length with the width as well. When you do cross multiply, you'll get the exact same thing. Okay, so two options, you just have to be consistent. Okay. I personally like to compare the length from one triangle to the other, like this. Okay, and example 2, using the same logic, yes, this is not a triangle, but using the same logic, we can apply it to other similar shapes. For example, this rectangle right here. Find the scale factor k. So scale factor means like how many times bigger or how many times smaller it is. So just looking at these two, can you see what is the scale factor? Yeah. 4, yeah. So k equals, choose the two sides. So 8 divided by 2, you get 4. So each of these sides are 4 times. Right? Times 4 times 4. So that's how you find your k factor, by dividing. What is the relationship between the areas in the pair of similar figures? So this is where I said, yesterday we started off with that triangle, and then we said it was 4 and 1/4. So this is where it comes back. So how do we actually find it? Why is it 4? All right. So for this small rectangle, 2 times 3, which is 6 meters square. And then for the big rectangle, it's 8 times 12. 8 times 12, which is 96 meters square. Okay. Now, if you compare these two area, 96 divided by 6, you get 16. Okay. What connection do you see from part A and part B? Yep.
B is K squared.
Yeah. It's K squared. So the connection between them, you know how yesterday we got 4 as well, but then we said, well, it can't be 4 every single time. What if the triangle or the rectangle is 100 times bigger? It can't be just 4. So where did we get 4 from yesterday? Where did we get 16 from yesterday? It's K squared. Okay, so area of the bigger thing is equals to K squared times area of the smaller shape. Okay, so this is a formula. Okay, so that's why the area of the bigger rectangle, it's K squared, which is 4 times 4, 16, times the smaller area, which is 6, and you'll get the 96.
Is K the variable we always use for the scale factor? Or just
Yes. Yes. Yeah. Okay. And why K? I don't know. They could have used S for scale or F for factor, but math is interesting. So they use K.
K from H and K.
No. Yeah, see? We have 26 letters, but they decide to use the same variable for different formulas.
Yeah. We should get more letters, like honestly.
they did. They used Greek letters. And they still don't use all of them. We had 26 choices. Okay, so example 3. This is supposed to say example 3. It got cut off. All right. So find the scale factor here. So part A, find the scale factor. All right, what is my scale factor? Scale factor, you compare the length. What is my scale factor? Right? Sorry? How did you get that? Yeah, and then you get 1.5. Okay, so you compare this length with this length by dividing. You can tell that it's by a scale factor of 1.5. So that means this triangle is 1.5 times bigger. Okay, and then find the area of ABC then, since we know the scale factor. We're going to use our formula. Area of the bigger shape times the K squared of the smaller shape. Okay, so what do we know? Do we know the area of the bigger or the smaller one? Hazel? The bigger one, so 72 equals K was 1.5 times area. It's a smaller one. Okay, so 72 equals 1.5 times 1.5 is 2.25. So when you divide it, 72 divided by 2.25, you get 32. Okay, what's my unit? Asha? Sorry? Centimeter square, perfect, because it's area. All right, and I know it's centimeters, not meters, because this triangle was given centimeters squared. Okay. And that's the lesson. Oh, that was fast. 10 minutes. Any questions?
When does the period end?
12.
Okay.
Okay. Yeah, so we have plenty of time. Again, you can either work on these in class and have no homework, or work with your partner on the decimal project and then work at these at home. Okay, so two choices. Make sure you use class time wisely. Okay.